maybe switch over to the screen you can see, maybe not this, but how about this thing? So yeah, good morning. We're having a little bit of an issue with our internet connection this morning, so hopefully that doesn't cause us any problems later, because as you can tell, our course is somewhat reliant on being able to connect to the internet. So this could be an issue with the stream, but hopefully that's not the case. You guys are here live and in person, so that's at least something good.
Yeah, if somebody's following, please mention in Slack, at least those who are enrolled in the course, so we'll be hopefully following Slack if there's problems with the audio and stuff. So
Yeah. But yeah, otherwise, there didn't seem to be any obvious questions in the Presimo responses.
yeah, somebody says crystal clear. So week 3 for loops, conditional statements. I bet some of you learned a lot. For some, it was probably already familiar, but maybe you learned the Python syntax for loops, indentations, writing readable code. Mm-hmm. Yeah.
Some of those things sound familiar, hopefully. So yeah, I think if there's not any questions here, what we thought we could start with perhaps is the optional problem from exercise number 3. Because this is a good way just to refresh you and get you back into thinking about for loops and things like that before we move on to our topic for today. So we'll start here. You hopefully made it this far down in exercise number 3 to this problem where you had the challenge of making a flag. It was a totally optional problem, so you didn't need to try to do this, but perhaps some of you did, and perhaps some were more successful than others in doing this. So we thought, since it's not for any credit points or anything like that in terms of the course points, that we could go through how to make this flag, just as a little warm-up thing. So I've got my Jupyter Lab open here already, and if you haven't, you can open up a CSC notebook or binder session, whatever you want to do. And I've just put this in an empty notebook for right now, and all I did literally was just copy paste the flag in here just so that we had this as a reference of what we're supposed to try to make. And so as you can see here, when I look at a pattern like this and sort of think about it like a computer, I tend to look at this and say, okay, how many characters wide is this thing, and how many rows of characters do I have? And there's different parts in here, and we can deal with the different parts as we go about making our flag. But basically, when we look at each one of these lines, each row in the flag, we can count the number of characters. There's 7 stars here, and I think there's then 12 dashes in this case. So total of 19 characters on each row, and you can see there's 5 rows in our flag pattern. That's going to set up how we can approach this with for loops, because basically we know we need to go to each one of these positions and put in some character, and we need to generate a pattern that does this for 5 rows and 19 columns or 19 character positions. Now, I think the way the problem was set up is you were supposed to start by making some variable called flag or something like that, so that when you printed flag at the end, it then generated this pattern. So we'll follow the instructions with that as well. So I've just put in flag equals just an empty character string for right now, because we're going to add some characters to that as we go. As I mentioned, we're going to need to do this with for loops, and we'll go ahead and do that first with a loop for the number of rows that we have. So I'm going to use the loop variable I, which is a typical variable to use. And we'll do for I in range. And how many rows do we have in this case? Well, we have 5. So that's going to determine how many times we go through our loop for the rows. In fact, we could even put a comment above here and say loop for the rows, just so we know what's going on. And so we've got this loop. And then the difference here with some of the earlier parts of the exercise is that this is meant to use what's called a nested loop. So we're going to have a second for loop inside here, And for j, we're going to have this loop represent which position we're at in terms of the length of each line. So we know we have to do 19 stops, so to speak. We've got 19 characters to fill in. So we'll put in here for j in range 19. Now, as far as the kind of heavy-duty thinking goes, we're most of the way done already. It might not seem like we've done anything, but we've thought about the pattern of how are we going to generate something that is 19 characters wide and 5 rows in terms of the dimensions of this character thing that we're going to print out. Now, because our rows look a little bit different in some cases, we have in some positions, like for the first 3 rows, we have to have stars for some of the characters. For the last 2, we don't. This is where we're going to have to use some conditional statements so that when we're within this loop, we're filling in the right character at the right position. So for instance, in our loop here for the number of rows that we have, we can add in a conditional statement that will treat the first 3 rows differently than the rows that follow. And we can actually just do this inside here. So we can say that if our character here, I, is less than 3, so that means if you remember the range function is going to give us numbers that start at 0, 0, 1, 2, 3, 4 in this case. So if we have 0, 1, or 2, that means we're in the first 3 rows. We're going to treat that differently. And we'll see. I'm just doing this from memory, so we'll see if this takes us down the right path. The good thing is we can print our flag at the end and find out. So if we're in a row that is less than row number 3, then we can add another statement in here that says if j is less than, and you remember here that we have the first 7 characters as stars, so if we can say if j is less than 7, so that should give us the first 7 positions, we know now that we're within this star part of the flag pattern. Because if our row is less than 3 and our column, or our sort of character number starting from the left side, is less than 7, then we're within the star part of the pattern. So what we can do here is we can say our flag can be equal to what's already there plus the character star. And so our flag, of course, starts out as empty, but as we go through here, we're going to put in a star in these different places. I think I'm doing this in a little bit more complicated way than perhaps the simplest way, but we'll see if this works. And since I'm here, I'm just going to add a couple comments to say this is our loop for the columns or character positions. And then here we're just going to say test if we're in row 3 or less. So first 3 rows, and then we're also here just going to test if we're in character position 7 or less. You don't need to add these comments necessarily, but all I'm doing is just using a little bit of logic and the sort of order of things to add the right character in the right position here, and we'll see whether or not this works. So if we pass this test that we're in the first 3 rows, and we pass the test that we're in less than position 7, that means we're going to put in a star. If we fail these tests, so if we're not in the first 7 positions in the first 3 rows, we're going to say flag. And I'll show you actually a different way to do this because it's kind of a nice little shortcut to know. Flag plus equals dash. This flag equals flag plus thing here is exactly the same thing as flag plus equals. It's just a shorthand notation, so I could, just as easily say flag, equals flag plus this, but because this is such a common thing to append, they've given you this shortcut option in Python to do plus equals if you want to do that. So we've covered our cases here that if we're in the right positions, we're going to add the right characters. And then we also need to catch the case down here that if we're not in the first 3 rows, well, here we know that we're going to be saying that our flag equals flag plus, in this case, just a dash, because that means we're down in these bottom 2 rows, so we're going to fill in just dashes there. So we've done most of what we need to do now. If we ran this as it is, the problem is that we're going to end up with a bunch of characters that are not necessarily separated onto different lines. So there's one other thing we have to do, and that is here in our first for loop. So remember, the indentation's kind of telling us where we're at. Everything we've been doing so far has been within this inner for loop. But here, if this stuff happens, this outer loop, the one for the rows, the last thing we need to do in here is we have to add a special new line character to indicate that we're at the end of the line and we want to then have the next stuff displayed on the following line. So here at the end of this, first for loop or outer for loop, we need to say flag equals flag plus, and then this \n, which is the escape character for indicating a new line. So that doesn't show up as a visible character, but it tells Python that that we want to have a new line displayed there. I don't know if I'm going too fast or if this makes sense or if the logic is kind of confusing. Maybe I've done things wrong. Entirely possible. So what we should do at this point is maybe run this and then print our flag and see what it looks like. It could be that, like, I feel like this is at least partially inspired by the US flag, and perhaps I've mutilated my home country's flag. So are there any questions at this stage? Like, did you follow kind of what I was thinking in terms of the logic here? And I know I'm going a bit quickly, and I'm not doing things in the kind of 2 parts of the exercise, like making the star pattern first and then doing this. I'm just doing the whole thing together. But we've now got whatever number of lines of code here that I've not tested at all. And we can run this cell. And don't get any output here, but if we go then print flag, we can find out if we got it. Ta-da! So that looks like we've reproduced our flag pattern as expected. So that's good. I didn't get a lot of sleep last night, so I was a bit concerned about doing this without preparing, but yeah, this is good. So just to recap very quickly, because I don't want to use too much time in our lesson here, but essentially, when you look at these kind of things, if you're asked to do something where you're going to have, like later in the course, we'll deal with data frames in this pandas. It's another, I guess, type of data and a way to represent things that are often in spreadsheets. With spreadsheets, you have rows and columns. When you look at these kind of problems and you're asked to go through and check values in some regular pattern like that, for me, I see this now. When I look at something like this, I immediately think for loop, and I look how many rows, how many columns. And then once I set that up in my head, I say, I've got 5 rows, 19 columns, or 19 kind of characters that are going to go here. Then I can start saying, okay, I can set up the outer kind of big structure. And then once I'm there, This first loop is basically things that are happening for each row, and then the second loop is things that are happening within each row at each position for the character. So that's where you can put these kind of logical tests inside this for loop, because I know in here that whatever's inside this part of the code, whatever's indented to this level, all this highlighted stuff here, this is all going to happen for every position in our flag pattern. So if I can lay out the kind of tests that I need here to check which row am I in, which position in the number of columns or characters, then I can pretty easily do something like make this flag pattern. Which is not to say that it's easy to do, but it's just once you kind of get the sense of how to attack the problem, it's perhaps easier than you might make it out to be when you're trying to do it at the stage, you know, a good number of you are at. So
yeah, maybe this exercise 3 problem 4 is one good example of problems that you can solve in many different ways. So if you solved it and your solution doesn't look like this, it doesn't matter. It's probably a great solution. I posted on Slack week 4 channel my solution where I'm actually not using the nested for loops at all. I guess one of the points in this exercise was to kind of be able to solve it also with the nested for loops. But I would think of it as like the 3 first rows has a specific pattern, so we have a for loop that goes over 3 rows, and then the 2 last rows have another pattern, and then you can do that. So you can check it from Slack. Yeah. Just another approach for solving exactly the same problem. Yeah. And sometimes one problem is more fast than the other problem, or more beautiful, or whatever. But then I think at least during this course, the number 1 goal is to solve the problem, and then we can start thinking how to make the code more efficient and such. Yeah. Yeah.
Yeah. There's lots of different approaches to pretty much anything that we would deal with. Any questions? Yeah.
Can you post this on Slack?
Yeah.
I'm missing something and figure out what is it, because I have 3 rows of
Yeah. Do you want me just to copy paste this?
Yeah, lovely.
Okay. Yeah. I will do that, but I can't do it just at the moment, but maybe I can open up Slack quickly. Let's see, week 4, and how do I put a code block in Slack? Is it triple?
Yeah.
Okay. So yeah, that one's in Slack if you want to copy paste that. Yeah. So shall we continue then perhaps here? We can go take a look at the course page, see where we're at. We're here to lesson 4 this week, and I'll take us to the lesson overview here quickly. So what we have is the concept of functions this week. And this will be one of the things, you know, last week we introduced for loops and we introduced conditional statements. And with functions, we're kind of adding our last big programming concept. And it's something that will take a little bit of practice to get used to using, but functions are really extremely powerful because it allows us to take some piece of code that we need to use over and over again and put it into its own separate little tool. So it's just like something like calculating the sign or using the print function. These are functions that are built into Python. But we can create our own functions as well to do things that we might need to do, like convert temperatures from one temperature degree system to another one. And that's, in fact, what we'll do in the lesson for today. After we talk about the kind of basic ideas of these reusable pieces of code called functions, then we'll talk about using modules in Python and libraries. We've already seen this a little bit, but just maybe expand a bit on what a library is and how to use them in Python. Essentially, these are just, you know, if you looked under the hood in Python, these would be files that have a whole bunch of functions in them, and you can then load in one of the libraries to use the functions from that, like the math library that we've already seen. And then of course we've got some little hint here about some good coding practices, and then a preview of exercise number 4. So that's where we're headed. And so our destination here is to talk about functions, and for that I'm going to jump over to the Jupyter notebooks and see if I can find myself the notebook for today, L4, and functions. And I'll get this little thing out of the way. Okay, so yeah, as mentioned, I mean, we'll make a function. We'll see what they're all about here. But basically, the idea is that you take some piece of code that you're going to need to reuse, and you make it into its own little separate thing, so that you're not copy pasting it every time you need to do it. So you might think something like converting time from time in years to time in seconds is like, well, that's easy enough. I know the conversion. I'll just type this in every time I need to use it. But I find myself even writing little functions or conversion factors for things like converting time from years to seconds, because every time you type something in, there's a chance that you type it in wrong. And if you type something in like converting time from years to seconds, if you don't remember how many seconds are in a year, there's a good chance that that you could make a mistake and not notice. So as mentioned here, it's also something like, you shouldn't repeat yourself in your program. This is kind of one of the good principles of programming, is you don't repeat yourself. That doesn't mean you don't reuse parts of your code, but it means you don't type that same piece of code in over and over again, because again, if you need to change something and you've done this, and let's say you've typed in the same operation 20 times in various places in your Jupyter notebook, you've got to go change it in 20 different places. If you can write a function that does the same thing, you change the function once and it then fixes things everywhere in the code, or updates all of the places that the function would be used. So let's take a look here first at the anatomy of a function, just to see what we're looking at. And we're going to do this by way of a familiar example, and that is converting temperatures from Celsius to Fahrenheit. So we can do first, create our first function. And we do this with a new keyword, something we haven't seen. So we've seen like for, we've seen if, else, these kind of things. Now we have def. And def is a keyword that indicates we're going to define a function. We're going to create a new function. After that, we're going to give our function a name. In this case, we're going to do just the same thing that's down below. So Celsius _to Fahrenheit. We'll just call it FAHR, so we don't have to type in all of Fahrenheit every time. And then the parentheses. So what's happening here is this is going to be the name of our function. And then inside the parentheses are any parameters or any values that we need to give to use the function. And in this case, we're going to give one value called temp. We could call it temp Celsius if we want to be clear, but we'll just call it temp here for the sake of simplicity. And just like a for loop or a conditional statement, we end this this line with the colon character that indicates we're done defining the name of our function and the parameters that it takes. If you hit enter, you'll see again, just like a for loop or conditional statement, that you automatically have this indentation that happens. That's because everything inside the function is indented just like it would be with a for loop. And in this example, we're going to right away hit another keyword, this case called return. And what's going to happen with return is that when you use the function, whatever is listed on the line with return is the value that will go back to you, the user, when you use your function. So in this case, what we want to return is our temperature that's been converted from Celsius to Fahrenheit. And so we can take that and just do 9 divided by 5 times temp plus 32, the ever intuitive conversion factor from Celsius to Fahrenheit. So what we're going to do is we're going to pass in some number here called temp. We haven't made our function super super safe, so we don't check to see that temp is a number, but we're just going to pass it in assuming the user has given us a number. We're then going to take the value of temp, multiply by 9/5, and then add 32 to convert the temperature from Celsius to Fahrenheit. And this number, this kind of value that's calculated in the equation here, is what's going to be given back when the function is used. If you run this cell, you'll see there's nothing that happens. And that's not to say that nothing has happened in Python at all, but we don't get any output to the screen because we've defined a function. So now we have the ability to use it, but we haven't actually used the function yet. We haven't given a number for the temperature, so we haven't done anything with it at this stage. You can see in the diagram down here basically the things that we've just mentioned about this def keyword, the name of the function, the parameter, the return statement, and the value. So all of that stuff is here in case you need a reminder. But at this stage we can go down a little bit, and we have already defined our function, so we can try using it. And so what we should do in this case is if we go to our next Python cell here, we can define a variable called freezing point with 2 E's. And we know that the temperature at which water freezes in Celsius is 0. So we can say, let's go with Celsius to var, our function name, with the value 0. So what this should do is convert 0 Celsius to some temperature in Fahrenheit and then assign that to a variable called freezing point. So we know what our Celsius to Fahrenheit function is supposed to do. The value we're giving for temperature in this case, or temp, is 0. And if we run this cell, again, we don't get any output because we're just doing an assignment. But we could now add a print statement that says the freezing point of water in Fahrenheit, or whatever, if you want to type something shorter, you can, is, and then freezing point. So what this should do is just print out whatever our converted value is from Celsius to Fahrenheit that's been assigned to this variable here. And if we run this and cross our fingers, we see the freezing point of water in Fahrenheit is 32 degrees. As we see here in the instructions above, we should get a temperature of 32 degrees Fahrenheit. Indeed we do. So it looks like our function passes one possible test. We could test this again with another print statement, just to kind of show you there's another way you can use the function. We could say the boiling point of water in Fahrenheit. Again, you can type something shorter if you want. Is, and so we won't define a variable here first when using our function, but we can just call our function in here. Celsius to var, and let's put in a temperature of 100 this time. And what we should see when we run this, in this case, as long as I have enough parentheses, is that the boiling point of water in Fahrenheit is 212 degrees. If you're lucky enough to know that, congratulations, but that is the right temperature. So so it looks like our function is working. We could probably break it. It's going to be hard, but we probably could break it. We could put in, Celsius to Fair with dog or something like that. You try and convert that, and that will break your function because, of course, it's not designed to handle number stuff and character string stuff together. So it's not a bomb-proof thing, but at least it looks like for the values that we know or potentially could look up for freezing and boiling points of water, the function is working. So that's handy. So as we saw, I think back in the very first lesson, sometimes we can have trouble converting kelvins and Celsius as well, as I nicely demonstrated. So we could also think that since that's something we don't want to screw up in the future, in embarrassing situations like sitting in front of an audience of people, that we could make a function for this to sort of allow us to convert kelvins to Celsius. And so that's what we can do here. We can define another function, in this case called kelvins, to Celsius. And in this case, we can say that let's give it a variable name or parameter called temp kelvins. It could also be called temp. It actually doesn't matter. Variables that are defined within a function, in this kind of def statement here, they exist in their own namespace. So they won't, like if we use temp in here and we use temp in our other function, it's not a problem. They don't interact with one another. It only knows about the name of the variable inside the function. So that's a good thing, because you don't have to worry about, like, what if somebody else in Python used temp in one of their functions? Like, obviously that would be a big problem. So this is a little different than when you define a variable somewhere else in a Jupyter notebook where it's in the kind of global namespace. If we defined a variable called temp somewhere in our notebook and then we use something with temp later on, it will take the values from the variable that's been defined. Inside here we're safe, but we can call it temp kelvins just to be clear. Again, it's nice for the users to look at the function and know what's going on. And in this case, we'll again have our return statement. So we've got our def keyword, the name of our function called kelvins to Celsius, and the parameter value, temp kelvins, that it will take. And then what we should do is, if we want to convert from kelvins to Celsius, we should take our temperature in kelvins and subtract 273.15. So we know, for instance, that 0 degrees Celsius is 273 kelvins. So if we want to do this, then we should do this conversion to go from kelvins to Celsius. Again, when you run this, you won't see any output because it's just basically storing this function in memory in the computer within this Jupyter notebook, and will allow us to then use the function in whatever way we might like. So one thing we might like to do is calculate a variable called absolute 0. And absolute 0 in this case would be, if we want to know what the value is in Celsius, we can say let's use our kelvins to Celsius function. And we can put in 0 here if we want. Just so that you can see as another example, we could also say temp kelvins equals 0. So if you know the name of the parameter inside the function, sometimes there are functions that have more than one parameter and you want to specify which one you're setting without having to worry about the order in which they're listed. You can define it with the parameter name inside here. You can also have functions that have a default value, and this is another way in which you can make sure that you're overriding what the default value is. I don't think we cover that necessarily in the lesson today, but I can show you an example of how to set a default value in a function if you're interested. For now, let's finish this and then we can talk about that. So we have absolute 0 that's going to convert 0 kelvins to the equivalent temperature in Celsius. This will not probably be a mind-blowing use of this function, but now if we print out absolute 0 in Celsius is, and then our absolute 0 variable name that we've just defined, we see absolute 0 in Celsius is minus 273.15, as we would expect. So if you have some functions where you might think they're going to often take a kind of a standard value. You can do things like inside the definition of the function. Just thinking, I'm pretty sure we don't ever come back to this in this lesson. So I'll just show you, as you know, for those who are interested, as a kind of little bonus thing here. We could specify in here a default value for temp kelvins. And what this would do is that when you use the function, we could actually then not specify a value inside here in the parentheses when we call the function. It will take the default value that's there. Let's use something other than 0 so we get a little bit different output. Let's put in 100 kelvins as the default. I don't have any reason why you would want to do that, but this will, when the function's called, will default to using the temp kelvins value of 100, which means I don't actually have to specify it when I define absolute 0. Let's call this absolute absolute 100 because it's not absolute 0 anymore. And then we could say absolute 100 in Celsius is absolute underscore 100. Whatever. This is a sort of nonsensical thing to do. But what you see here is that we haven't given a value of temperature here, but our function still works. And that's because this is a function that has a default value specified, meaning you don't have to separately tell it the number that you want to use. If you don't give it anything, it defaults to temp kelvins equals 100. And then you see here, okay, we've got a little round off issue that instead of getting minus 270 or minus 173.15, we get minus 173.1499999, blah, blah. This is not to say we can't give a temperature value here, because we totally could just give it something else. You know, if we wanted to say absolute 50, again, this is not sort of the way in which you should probably refer to these temperatures. I don't believe any of these actually are real things that exist. But we could give a number here in our function and calculate absolute 50 as kelvins to Celsius 50. And we could print that out the same way. So there are times when you have functions that are going to sort of have a number of parameters that are default things. If you think back to the print function, I think maybe last week I showed you an example of how you can give a different line ending with the print function using this parameter, I think it was just called end. So the default in the print function is that the ending character for a line is a new line. But if you say end equals something else, then it replaces that default value with whatever you specify. So yeah, that was a little bit of a sidetrack to talk about default values, but just to make you aware. All right, now we have a task for you, and that is to check your understanding about functions, and you can do that by creating a function in this little Python cell down here. What your function should do is define a variable called output, and that variable called output that you will define will be what you define when you call your function. In your function, you should have two parameters. One should be name, the other should be age. And when you use the function, those should be things that can be defined, and that the output then should be to print out something. When you type in print output that says, hello, my name is whatever your name is, I am whatever age, years old. So that's the task. And we'll be wandering around for a few minutes here while you try and do that, and then we'll continue in the lesson after that. This is obviously not the kind of thing where we can have like a poll for your responses. So so give it a shot, and if you have questions, let us know maybe.
don't have internet connection, maybe borrow a friend's hotspot or something like that if EduRoam is failing us. That's what we're doing.
Later.
We could add.
Pandas or something like that. We could do functions. It's useful for places.
Yeah, it is.
Well, though, your phone. Did you check the stream working? So I'm streaming off my phone, so I don't know if like the bandwidth is probably not excellent. Just curious if it's just a pixelated mess or if it's actually usable.
I don't care to look at the videos at all.
Yeah. I've checked them a little bit just to see. It's decent. Alright. That's good. I mean, I think it does like adaptive resolution, so I just think that if you have a sufficiently slow connection, then like you get this. Yeah. Pretty bad, I think. Yeah, no, that's the default. Yeah, I don't know why. Nowhere else does it matter, but they do say even in the pet guide that we should use triple, double quotes. I use single quotes almost all the all the time otherwise.
Yeah, exactly. I guess they just like, well, let's pick one that one or the other.
It's interesting in Python that like single quotes and double quotes are different in within the operating system in Linux or Unix. They're treated a bit differently. So like you could put like variable names inside of double quotes and it gets converted to like the variable value to be printed. But if you put it in single quotes, it then prints out like the actual string of you trying to refer to the variable name rather than its value. Thank God it's not the case in Python because that would be just miserable to try to explain the distinction. Okay. So how are we doing here with the function to print your name and age? Has anybody managed to get that to work? Maybe by show of hands, who's got it working? A few? Does anybody want like 30 seconds more, or should I can continue and show you how I would define this function? Is there anybody who wants just a little bit more time to finish what they're working on, or shall we continue? I guess if you want more time, you should somehow indicate that, like raise your hand or something. Okay. Well, I think in the interest of time, we'll move on here. So yeah, we've got two things we need to do here. One is that we need to define a function, and then we got to print our output and see what our function produces. So we were told here in the instructions to make a new function called hello that has 2 parameters. So, well, let's start with that. We're going to define a function called hello. And our function should take a parameter called name and a parameter called age. Now, if we give it in this order, then it's also expected that when you use the function, you give the name first and the age second. The return value in this case is the string that we want to have printed. So in this case, we're going to return something with some quotation marks and things like that. So we should say, hello, my name is, and then we can, I guess, let's do it this way. We'll do plus name, and I'll add some spaces here just to make this a little easier to read. So name is going to be a character string. We would expect that to be the case for this variable that comes in. So hello, my name is, and then end our quotes, plus name plus a period here. So there's supposed to be a period after the name. I am, and then we've got another plus here. And we can't just put age in directly here because age is a number. So it's going to be most likely, unless you decide to put yourself in there with like decimal numbers, it's probably going to be an integer. But we need to convert that to be a character string using this string function. So perhaps if you got this far, you might have gotten tripped up here remembering that to do this, we have to convert age into a character string to be able to add it into our thing here. And then years old period. So this should take our name and age and return, hello, my name is name. I am blank years old. Okay, that's our function. We can define that. And I'm just going to add an extra cell underneath here to use it. So if we say output equals hello, and for the name, we can say, I guess, my name in this case, and we'll do my name and my age, and then we'll print output. So we've defined our function up here. We've got the name and the age. We see how it works. When we'll just assign whatever comes from this function to a variable called output, and then print output. And when you run that, you see, hello, my name is Dave. I'm 39 years old. That looks pretty familiar, and works as it should. Now, you'll note here that in the use of this function, we do have to give things in the right order. So if I said the age first and then the name, and tried to use the function, we're going to have a type error. Because in this case, what it's trying to do first is put in a number here as the name. As far as the function's concerned, it sees these 2 parameters. Whatever's in the first position is getting assigned to the variable name. Whatever's in the second position is getting assigned to the variable age. But there is a solution for this. When you've got functions that have several parameters, it can be kind of annoying to try to remember the name and the order of them. So we could say age equals 39, name equals Dave. This will ensure that our values get assigned to the right parameter in using the function. So now this works. So if you find yourself making some simple functions, if they've got more than one parameter, it's not a bad habit to get into actually giving the values in this format where you specify the name of the variable equals something, so that if you flip them around in the wrong order, you don't end up causing yourself trouble. If it takes a single value, then there's really, there's not much benefit to specifying the names of the parameters when using the function. But does this make sense? Yeah? Okay. So, now we get our dated meme reference here with functions within a function. So this is kind of a nice thing that if we now wanted to make a function to convert from from kelvins to Fahrenheit, remember we have so far something to convert from kelvins to Celsius, and we have something to convert from Celsius to Fahrenheit. If we want to go from kelvins to Fahrenheit, we can make a function for that as well, and we can take advantage of the fact that we've already defined some other functions in doing this. So again, since we're making a function, we'll define it. And in this case, our function is going to be called kelvins to Fahrenheit, kind of sticking with the same naming tradition that we've had. The value that comes in is going to be called temp kelvins. Doesn't really make a great deal of difference, but let's call it temp kelvins this case. So here's our function name, parameter called temp kelvins, and then the colon at the end of the line. What we're going to do differently here is we're going to take advantage of the functions that we already have. So inside of our kelvins to Fahrenheit function, we can start with defining a variable called temp Celsius. And you might be going, wait, why we've got kelvins to Fahrenheit? Why is Celsius coming in here? There is a reason. And the reason for that is that we can use our function kelvins to Celsius that we defined earlier to convert this value that comes in at temp kelvins to a temperature in Celsius. So we're just going to store the output of this kelvins to Celsius as the variable called temp Celsius. We can then create another variable in here called temp var. And this, if you can guess already, is going to be where we convert from Celsius to Fahrenheit. Again, using the function that we've already defined. And in this case, the value that we want to convert is temp Celsius. So this is handy because we've defined these functions earlier rather than having to redo the conversion inside our kelvins to Fahrenheit function. We take advantage of the fact that we already have functions to do parts of this. We've got something to convert from kelvins to Celsius. We've got something to convert from Celsius to Fahrenheit. So when we want to go from kelvins to Fahrenheit, let's just use the functions we have. In the end here, of course, we need a return statement. And in this case, the value we want to return is just temp Fahrenheit. Do you see what's going on here? Get the idea? Yeah, just taking the pieces we already have and taking advantage of the functions. In order for this to work, we do have to define this temp or this kelvins to Celsius and Celsius to Fahrenheit functions first before we run this function. That is a kind of required first step. We can't do this without defining those functions first. But if we do this and then run the cell, again, we don't see any output because we're just defining the function, but we can use it. And let's now make an absolute 0 Fahrenheit. And that's just going to be the value when we do kelvins to Fahrenheit. 0, right? So 0 kelvins converted to Fahrenheit. We run that. We don't get any output because we've converted the value. We've now stored it in this variable absolute 0 var. And now we'll do like we did before. Print out something that says absolute 0 in Fahrenheit. Rather annoying to type in every time. Is, and then our absolute 0 FAHR. If you run this, this will then print out something like this. I don't happen to know that this is the right value for absolute 0 in Fahrenheit. It looks pretty good. So, if we wanted to test that our function was working correctly, it would be a good idea to put in something that we know. So instead of putting in 0 degrees for absolute 0, okay, without redefining the names of the variables, we could put in something that we are more familiar with, like 273.15 should correspond to 0 Celsius or 32 degrees Fahrenheit. I'm not changing the names of the variables. I know I should. I should also change the print statement. But this is just a quick way to test that when we use the function, we get a value that we know is the correct one. I don't know the number value for kelvins or for absolute 0 in Fahrenheit, but I do know that if I put in 273.15 kelvins, that I should get back 32 Fahrenheit, because that should be the freezing point of water. So it looks like the function works. At this stage, we're going to switch gears a little bit and talk about script files. We've been mostly working so far in this Jupyter notebook environment, and there are some cases in which we're going to want to use a little bit different system for doing our Python programming and using our Python code. But I think perhaps we'll take a break just a tiny bit early, because otherwise, once we get into the script file stuff, it's good to kind of make it through that piece of the lesson uninterrupted. So why don't we come back in 15 minutes, and then we'll continue with script files and then on to the other parts of the lesson. All right? So 10:30. folks. I think it's nearly time for us to continue. And so we'll do that. And as mentioned, we're going to move on to talking about script files now. And I think first off, just in terms of the concept, they're not really that different from what we're doing in the Jupyter notebooks right now. Essentially, what a script file would be just taking the things out of the code cells we have in our Jupyter notebooks and putting them into a separate text file that we call a Python script. That's actually the way that Python, well, in fact, that's the way we taught Python programming in this course up until last year, was that we were working in these script files and using a text editor to put information into the script files to run Python programs. The Jupyter notebooks are in many ways nicer because we can have lots of text describing things, we can embed images and all that stuff, so that's why we're working with them now. But there are instances where a script file is better than a Jupyter notebook. And a classic instance of that is if you have a bunch of functions you want to use, but you don't want to clutter your notebook up with like a whole bunch of cells defining the functions. You can put them all in one script file and then load that script file to be able to use the functions. That's what we're going to do right now, is an example of that. In terms of what the script file is itself, maybe sounds like something special, but it's not. It's just a text file. And a Python script file traditionally would be a text file that ends with the file extension .py. As you've noticed with the Jupyter notebooks, their file extension's .ipynb. You might remember that's IPython notebook, going back to the old name of Jupyter. But .py is typically used for a Python script file, and we'll follow suit with that in what we do as well. We can create the script files themselves right here inside Jupyter Lab, so that's handy. And the way that we'll do that, you can see in the lesson here is described, but we can also just follow along. If you go to File, to New, and then here to text file, because that's what a script file is. It's basically just a text file with a .py file extension. So that's created our empty script file, and well, I guess if I just want to make sure that I'm in the right spot in the lesson now that I've lost my view of what we're doing. So the default name that it's given here is untitled.txt. If you right click on that, you should be able to go to rename file, and we'll give this thing a better file name than untitled.txt. So we can call it instead temp_converter. And again, we also want to get rid of this .txt file extension, so we'll call that .py. So when you rename the file, it should be something like tempconverter.py. Most probably, if you're following along in the CSC notebook system, you'll see this file path, notebooks/L4, and then the old file name is untitled.txt. The new name is temp_converter.py, and I'm just going to hit rename, and now you can see the name up here has changed. So far, so good. Now, jumping just back here to this functions the functions lesson. Inside here, we have our first function that we're going to put in our script file. It's our familiar Celsius to Fahrenheit conversion function. I'm just going to copy that. So copy and paste over here to the tempconverter.py script. So this is essentially what we would have typed into a Jupyter Notebook Python cell before, and Celsius to Fahrenheit, all this stuff looks familiar, hopefully. Now we've renamed our file, and we've added some text in here. And this is just a regular file as mentioned before, so in order to save the changes, we need to go to File and then Save Python File, or you can do Control S or Command S if you're working on a Mac to save the file. And you should then have a file called temp converter that has been created with some one function definition in it. So if we go back to the lesson here for just a second, this is getting a little bit clunky. Maybe what I'll do is I'll show you a kind of handy thing about the Jupyter Lab system. We can take our tempconverter.py file, and if I grab and like just click and hold the tab for temp converter, I can drag this thing down here. I'm going to put it in the lower half of what we can see, and then drop, so that now I can see the functions notebook and our script in the same view. I could have put it on the right side or left side. I think with how far zoomed in I am, it's easier to put it underneath, but maybe on your screen it's easier to have things side by side. If you grab that tab, you can drag it around to different positions and see what all the possibilities are. Kind of a handy thing in Jupyter that you can rearrange the layout in that way. That's yeah, a nice thing. But what it means is I can also not have to go back and forth between the tabs, because there's a couple other things we have to copy and paste. We've renamed our file already, so that's good. We can skip past that renaming part, and we're going to now take a look at loading in some of these functions and using them. But before we do that, I'm going to grab these other two, Kelvins to Celsius and Kelvins to Far, copy those and paste them in to our script file. So you should then have these three functions, things that we've already defined earlier. And then as it says here, don't forget to save your changes. So we'll do that, save the changes to this temp converter file. And now if we want to use this, we've got to do a couple things. First off, we have to make sure that we're in the right directory to find this script file. So the first cell, I guess, you know, it's handy if you guys have all got this set up the same way, or if you want to go back to the functions lesson. In this section about making sure we're in the right working directory, we can use something here that's what's called a magic command in the Jupyter system or IPython called %ls. That's going to list files in the directory where we're working right now. And when I run %ls, this then prints out the files that are in this directory. So I see functions, modules, writing scripts, and here's the temp converter.py. So is there anybody who doesn't see the temp converter when they run this %ls? I don't know if you do this on Binder, for instance. I think so. Yeah, I guess maybe if you don't see that, there are some instructions underneath here about how to change directories and things like that. I'm guessing almost everybody else is able to see this, so we don't need to go through those instructions about how to change directories, because it depends on if you're Binder or CSC notebooks. And so I'm going to assume, unless you make it known, that that you see tempconverter.py when you run this %ls command to list the files. If you do, that's good, because we don't have to worry about changing directories and things like that. If you're having issues, again, just let us know. Vuoko is available to assist, and Lotta is here as well, so we're happy to help. So again, there's another cell down here for after you've changed directories, if you had to, where you can do this %ls thing. Again, we should see tempconverter.py here. So I've just scrolled down in the lesson a little bit. Now, if we want to use some of these functions, we can do that by importing them, by bringing them in the same way that we would import like the math library or some other library. But we'll do this, in this case, by importing a single function to start. So from temp converter, import Celsius to far. The way in which the libraries work in Python, Vocal we'll talk about a little bit in the part of the lesson that's coming up here. But essentially, when we use this kind of code like this, where we say from something, import something else, this is going to go looking for a script file called temp converter. We don't have to add the .py because it's an assumed file extension. And it says, okay, well, I'm going to look for something called temp converter. And when I find that, I'm going to look for a function or a value called Celsius to far and bring that value into the memory that makes it then usable. So this means that we should basically take our temp converter script, read it, find a function called Celsius to Fahrenheit, and then make that usable to us for whatever we have in our interest in converting temperatures from Celsius to Fahrenheit. So what we can do is something that's very much like what we did before, and that is we can print out a temperature. We could say, print freezing point. I'm going to kind of make this a little bit shorter. And then Celsius to far 0. Maybe we'll add freezing point in Fahrenheit. And then Celsius to far with the value 0. So this should be using the function that we've brought in called Celsius to far from our script file. If we look down here in our script file, temp converter, that is the first function that's listed there. So if everything goes well when we run this, we see freezing point in Fahrenheit 32 degrees, which might look familiar. Of course, we can bring in multiple functions from a single script at once. We could bring in all the functions from a script. We'll see that in just a second here. But if you want to bring in multiple functions from a script, you can say, from whatever the script name is, my script in this case, import function 1, function 2, oops, shouldn't double click to select that text. Function 1, comma, function 2, whatever the function names are separated by commas. So if you want to bring in a few of them, there are some instances where you might have, dozens of functions. Maybe there's some of them that are a little bit heavy to import, so you only want to bring in, certain ones. But you can do this as well. So like we could say, from temp converter, import Celsius to far, comma, Kelvins to Celsius, and bring in those two functions to memory to be able to be used by us. The more familiar way to do things would be to do something like this, where we type import temp converter as TC. So this is a very common thing that we'll see in our use of some other Python libraries going forward, where we import, in this case, we're going to import from our script everything that's in there. And we're going to give it a different name to be able to refer to the functions that are in the temp converter script as just TC, because it's shorter to type that in. And having to type in temp converter and the name of a function would be kind of clumsy. But this is sort of like what we did when we brought in the math library, but we didn't rename math because it's a short name for the library. There are others that will regularly rename when we're using them. So this will make all the functions in temp converter available. So we import temp converter as TC, and then we can do something like TC dot Kelvins to far and put in the value 0 and run this. On the lesson online, you can print out some extra text with this. I just want to show you that the way it works is that now when we want to refer to a function from our temp converter script, we refer to it as TC. Here is basically what we've done is we've imported it and renamed it at the same time. If you do tc and then dot, what's expected after that is the name of some function that's part of the temp converter script. So this is the way in which you could potentially print out values for the different functions in our script. Put absolute 0 in Celsius, Fahrenheit, freezing point of water in Fahrenheit, whatever. You could use all the functions that are here in the cells that are listed below, but I think that's just going to be a bunch of sort of excessive typing, and you won't necessarily learn anything from typing that in. The key point is that you give the name of the script file, or the name of the script if it's been renamed, in this case as tc, and then dot some function name. Now, beneath here, there is an additional piece of the lesson about creating a temperature calculator, where you have the option to specify what kind of conversion you want to do from Celsius to Fahrenheit, or from Kelvins to Fahrenheit, or whatever it is. I think it's Kelvin to Celsius or Kelvins to Fahrenheit. And there's some additional stuff there that's given in the lesson about how to define a function to do this. You can copy paste this stuff into a Jupyter Notebook cell or Jupyter Notebook Python cell and see how that stuff works. But there's one other thing I just wanted to cover briefly in here about the script files, and that is something called a docstring. So when we've got a bunch of functions in here, most of the users are never going to go and look at the contents of like this temp converter.py. So if you've created some little Python code and you want to share it with other people, they might want to know how your functions work, but they probably don't want to go and like read the code of the function to know what it does. And for that, there is a thing called a docstring that provides a little bit of documentation about a function without having to have someone go and actually read the code to understand what the function does. So I'll show you an example of a docstring, and then maybe we'll take any questions that you might have. Sorry. So the way it goes with these docstrings is they're basically just a little piece of text, and typically, in fact, I think it's basically required that they're given in the first line that follows the definition of a function. And they also use this rather unusual format to indicate that this is a docstring and not some other text related to something the function does, where you have triple double quotes. So all the text that's contained within here, so these are 3 sets of double quotes. It will work with single quotes, but the PEP 8 guidelines for writing nice Python code says you should use double quotes. I don't have any idea why, but inside here with our Celsius to Fahrenheit function, as an example, we could add some text that says converts temperature in Celsius, or in degrees Celsius, to degrees Fahrenheit. This is like a one-liner that very briefly says what your function does. We can have docstrings that provide much more information, but for a simple function like this that does one thing with one value, let's just give a simple description of what the function does. So we've added the docstring. We're going to save this now, because in order to be able to see how this works, we need to save it. And we've got to go here and do one other thing in our functions notebook, and that is we have to restart the kernel for this notebook in order to reload the functions that we've defined in our temp converter file. This is one of the things that's can be a little bit frustrating when you're working with a script file, is that if you make changes here and you want to reload, there is no option that's a simple thing to reload the functions in a Jupyter Notebook. It's easier here to go up to kernel and use the restart kernel option. That basically clears everything out of memory that's in memory now, so that when we go to reload our temp converter script, it all gets refreshed in memory. So I'm going to restart the kernel. It tells me all variables will be lost. We can live with that. And if I go back to this cell here about importing all the functions from a script, we can now import temp converter as TC, just like we did before. That works, and you can see now that when you do that, you get number 1 listed here as the order in which things have been executed in this notebook. That is because we've restarted, so this is now the first thing that's happened with the new kernel. And if we take, for instance, our Celsius defer function, I guess I'll just go down to this empty cell here. We can see our docstring if we type help and then tc.celsius to FAHR. So you remember this help thing works like when we used the range function, we saw how to use the help. Well, here we can look in our temp converter script at our function called Celsius defer, and if we run help with that, we then get this thing. It says help on function Celsius defer in module temp converter. And then it shows us here what the format is when we call the function. It's expected to say Celsius defer with some single number, temp Celsius. And then we get the docstring. It says converts temperature in degrees Celsius to degrees Fahrenheit. This is a very good practice to get into when writing functions. Adding a little one-line docstring about how it works can be helpful not only for you, but especially if you share your code with somebody else. They want to know how your function works, or if one of us is grading your exercise and you've created some function we didn't anticipate, maybe we want to know what your function's supposed to do. And this little one-line description here can be super helpful. You can go on if you want and give, multiple lines describe, that the value for temp Celsius should be a temperature in degrees Celsius. It must be a number. I mean, you could give a whole bunch of extra stuff there if you want. But just adding a single line makes this function much easier to use. If we go and look for help for some other function in here, like tc.kelvins to Celsius, all we get is just this little piece here that shows us the format of the function and that it takes one parameter called temp kelvins. So because there's no docstring, we don't get any additional information, and that's sort of unfortunate. But yeah, I think that kind of covers it for the basics of using functions. We'll now talk a little bit about modules and things like that, but are there any questions? Yeah.
So to get this statement to appear in the help, like when you ask for help, do you have to put it exactly under where you define the function for it to populate?
I think that's right. I have not checked what happens if you put this someplace else, but it's in many ways it's kind of the most logical place to put it anyway. I think the triple double quotes is something it searches through and finds that. So my guess is it probably would still work if we just cut this thing and put it down after the return statement. This may still work. I don't know. We could try it. So I've got to restart the kernel again. So let me do that. Restart kernel. Re-import the function. And if we look at the help here, no. So yeah, it has to be that first line after the function definition. Good question. Are there other questions about functions in general, about docstrings? We'll talk a tiny bit more about docstrings in a moment. But yeah, any things? Does this kind of function idea make sense to you? It takes a little bit of practice in terms of understanding the variable names, because sometimes you'll have a variable in your code and you use it in a function, and it's easy to kind of get mixed up between the function's variable names and the code variable names. So you'll get some practice with that in the exercise this week, but the key thing is just to understand that this gives us a little reusable block of code to do typically one single thing. So convert a temperature, print something out, It shouldn't be like a function that, you know, calculates how much money you've saved in the last year and how to optimally invest it, and then what you should do for retirement. Or I mean, it shouldn't do like, you know, tons and tons of different things. You should have one function to do one thing. If you have to do multiple things, you have multiple functions, and that's the kind of the principle here. So I think we'll switch over maybe to Woko. Do you want your mouse?
I think I'll be fine.
Okay. Do you want me to flip the scrolling thing?
You can, thanks.
Um,
If you do that.
so yeah, if there are any questions while we're switching gears here. Yeah. Then I guess what we'll do is move on to what? Modules.
Modules. Yeah, so basically I'll be kind of repeating what Dave just taught you basically, and maybe bringing it up to a more general level. So this is should be a short section, but let's see. Oop. Okay, the mouse works, so just move up a bit. There we go. All right, and we have lesson in here. So in terms of the lesson structure, we now covered basic concepts of functions. Yeah, that was it. So we'll continue with loading and using modules. I'll open it in here, and I'll just go ahead and open the student binder. You should have this available in the CSC notebooks if you already have that open. Let's load that. So I'll start in here. So modules, we've been using those a bit, but maybe not stopping to define what they actually are. So you just created a little module with this temp calculator, was it called? Can you give me those two papers from there? Thanks. Refer to the correct names. Temp converter it was. Then you might hear the word packages, libraries. So the whole point of writing functions using modules is to kind of make your code reusable, reuse your own code, reuse other people's code, and then build on top of that then new applications. So in principle, as you just saw, so Python module is basically a Python script file ending py, which has some functions, some statements that you can then import to other modules, other scripts, and run from there. And then if we talk about packages, those are kind of bigger entities, maybe multiple modules that you can then use and share with others. And then we might also talk about libraries. So for example, the NumPy library or Pandas library. So libraries are also packages, these more established sets of script, mostly in Python, but then we can also import some modules or libraries. Libraries or packages might contain also code that is not written in Python. So if we have these more sophisticated packages, and then of course sometimes we might use these words module, package, library a bit as synonyms, but in practice a Python module is kind of a single Python file with some functions and definitions. Okay, I think my binder is still loading, so let's check. I can also open it from here. And I think we can this, but that's not boring. Sorry. Yep. Well, let's continue here. So loading modules, I think already in the first lesson in this course we have imported the module math. So there's the import statement that we use to make some code available from a module, another script file, then to our notebook or our own little piece of Python code. So the syntax is import module name. If you run that, you'll have the module kind of in the active in your namespace, or the word math is then reserved for that module. And by doing that, we make available all the functions that are related to that module. For example, the square root function, which takes a parameter and then returns the square root of that value. Let's see if my binder is yet. No. I think I loaded it already once. Yeah, sorry for jumping back and forth. So that's pretty simple. And then, of course, we have also used some functions regularly without calling kind of module name dot function name. So Python has a bunch of these built-in functions also, such as the print statement, that are always available without having to import any module. Kind of technically, these built-in functions belong to the built-ins module, but we don't need to care about that. You can just call print something and the function is available. But then for these other modules, for example, math, you can't take a square root using the function if you haven't imported the module. Okay, so then we can also, okay, let's forget about that binder. So you can, while importing modules, you can also rename them. This might be useful, but it can also be risky. So yeah, but for example, with math, you could do import math as m. So once you run this cell, the letter m, or the kind of variable name m is reserved then for this module. And in the same way, module name dot function name, you can access a given function that belongs to this module. And if we check, indeed m is a module now in this instance. Now that we are running this particular Jupyter notebook that imports math as m. So we'll be using this sort of import statements in some cases. So for example, next week we start using the data analysis library pandas, and it's a custom to import pandas always as PD. So next week we'll be doing PD dot functions related to pandas data analysis library. And there's other examples. So maybe the good practices for these popular libraries and packages, maybe don't invent these short aliases, but then if it seems to be a custom to use some shorter version of the package name, go ahead and use it. Yep. Okay, so let's take another example from the math library. So as said, when we import the module, all the functions that belong to the module become available. So previously we imported this temp converter, but actually I think you only imported the specific functions. We didn't do like import temp converter. We did from temp converter import function names. We did both. Okay. So indeed, in some cases, you might want to do make only maybe one or two functions available from a specific module. So with this type of syntax, then you don't need to write module name dot function name. You can directly refer to the function name. And here, the thing is, if you haven't imported the module itself, and you only import one function, you can only use that one specific function. So now I couldn't, for example, do math.py. Actually, now I can do it because I have imported math in several different ways. But if I would restart the kernel, let's see if this is risky. Just a second. I only import the square root function. That works. And then I would try to do math dot. So then some other constant or then another function from the math library, then Python would give me the error that math is not defined because I haven't imported math, I have only imported square root. So it depends a bit on the situation. If we have a massive module, for example, matplotlib we'll be using in week 7 for plotting, so we only want to import specific subparts of the module and not to kind of bring in all this unnecessary stuff. Which is shown in here. So we'll come back to this during week 7, but there's this quite nice plotting library, matplotlib, and a submodule pyplot. So in this case, pyplot is kind of a module within a module in a way, or module within a package, or package in a package. We can check how it is actually. So we are actually importing kind of module.submodule as PLT. And here this PLT is a convention for renaming this pyplot submodule. And after doing that, we are then able to call pld.figure. This looks now a bit cryptic, but what it actually does, it kind of initiates a figure object that then we could start plotting maps or graphs or dots or whatever onto it. But you'll learn that in a few weeks. But maybe here again, if I import only pyplot, I can't access any other things in the matplotlib that are not under pyplot with this syntax. So sometimes you might be like, why this function doesn't work? I imported it, but you have maybe then imported some submodule or used another name, or maybe with pandas you try to do pandas.something and you have imported pandas as PD. So these sorts of things. So indeed, module name .function name is then often the way in which you can then access these functions from other modules. But then of course, like especially when beginning, the question is that, so what all functions are even available, especially if it's a module that you haven't written yourself. We know that the temp converter had these 2 functions, and you can import those and you know how to call them. But then especially these kind of readily available modules or packages often have numerous functions available. So there's a few ways to check what was the actual syntax or what was the name of the function. Okay, so now we need to actually import math and then check the contents of the module. We can do it using kind of is it a directory function or dir function? I think this is a bit difficult to read, so it provides a list of functions that we can use with module math. Personally, I prefer to use this more interactive way. So if you start typing the name of the module or package, and then you do module name and the dot, and then you press tab. Oops. So then you'll get an alphabetical list of available functions. If I want to go, I can press S on the keyboard, S, sin, square root, so I can then press enter. So I don't have to memorize all these like module name dot function name. Python always knows what's available, so it's good. And also it's whenever possible, try to avoid typing things. So this is one way to kind of get a quick a shortcut to the functions and to browse through what was actually available. Yeah. So next week when we start using pandas, maybe I'll, scroll up a bit. Where did we have? Here, import pandas. Then I could check a bit ahead, like pd.tab. Okay, there we go. So then there's, for example, read CSV. So we'll start interacting with actual data files using file reading function in pandas. Okay, so I'll jump back to where I was just now. Checking the functions, that's one helpful thing. And then I think Dave already showed this. But indeed, if we have a function, if it's something that we wrote ourselves, or if it's something available in a readily available package, then we can call help math.syn. And if you would go and look at the source code, this would be the kind of documentation string, the doc string of the math.syn function in there. So also these kind of official, well, by default, these official established packages always have some kind of documentation about the whole module and then about each function. Yeah, and then maybe something we didn't mention. Well, I'll come back to that a bit later. So that's basically all you need to know about accessing modules at this stage. Just make sure if you are calling, you have a Jupyter notebook and you make a script file and you want to import your functions or the whole module to your Jupyter notebook, just make sure that they are in the same folder. I guess that's the most common mistake. So Python looks for the module, in this case, in the same root folder. So what should I not do? So what should we all not do? Generally, it's discouraged to do like from module import star. So that would import all the function names in the module, and you could use those without calling module name.function name. But that's a bit risky because then you might have, if you import many modules and you might have same function names in different modules, and then you don't even know which package does this function belong to anymore, so you kind of lose control of things. Yeah?
Yeah, I mean, there's a good example. There's a library that we'll see called NumPy. We won't get into it in any detail, but we'll see it. And it does numerical stuff, like you can calculate sine function, you can calculate cosine, whatever. Obviously, you can do that with math as well. And if you do import, from NumPy import star, from math import star, depending on the order in which you do that, the sine function, does it come from math or does it come from NumPy?
Mm-hmm.
And there are some subtle differences in terms of how they work that might cause trouble.
Yeah, I think I used to use R quite a lot. I think many of you have used R. So in R you load the libraries, and isn't it so that you don't do library name.function, but you only call the function? And I think that was, at least for me, a confusing thing, because you might end up with functions with the same name from different libraries, and then you don't know actually which tool you are using. So that's hint number one. Then the other hint, just to repeat, so do use this kind of aliases when you see others doing it. Maybe that's not a good advice. But then, for example, you might be tempted to import matplotlib as m, because matplotlib is so difficult to type. But then that the m is kind of reserved for math, and that's also not even super necessary. So just to try to avoid confusion. Yeah, and then the final thing here, so again, last week we met PEP8. So of course here there are things you can do and they work, but then we can do things in a nice and beautiful and structured way. So in this Jupyter notebook, I now kind of imported modules along the way. Um, what PEP instructs is to always import modules at the top of the script file. Of course, now we're using Jupyter notebooks, but at the end of the day, the Jupyter notebook is also just kind of a piece of Python code that runs from the top to the bottom. So following the PEP guidelines would be good practice to always have, if you're importing modules, let's say 3 modules, use the first code block. You might have some documentation, or this exercise is about blah, 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 motivation, literature, and then you'll start your analysis. So the first code cell would contain the import statements. We also might not be doing that always, but that, I think that's a good practice. And also because essentially you could even, there's a way to convert Jupyter notebooks into Python scripts and just run them. So in that way, if you end up doing that, you already have things in the right places. Any questions about importing modules, packages, libraries? If you want to get super technical definitions, there's some links to the Python official documentation, but they're quite intuitive. And by importing, we make functions, statements available in other scripts in our own script. And by documenting them, we help others to understand how to use them. There's a little extra block that is in no way required, but I know that some of you are working on your own computers, and of course now that you're getting more familiar with Python, you might want to install the tools eventually on your personal laptop. So we have some semi-outdated instructions on how to install stuff. So basically you would install a package called Anaconda. And then of course, now that we are importing modules, we can only import modules that have been installed. So in this binder environment and in CSC notebooks, we have prepared the environment so that there are the modules that we need in this course available. Maybe one more example, if I would, I'll just add a code cell, you don't need to do this, but I'll do import GeoPandas, which is a cool package that we'll use during period 2 with the AutoGIS course. Oh, actually it did it. Well, that's a bad example, but if you try it on your own computer, that's weird. Maybe on the CSC notebooks, yeah, on the CSC notebooks it works.
Yeah, the binder is, I don't know if it's died already, but your binder tab is...
Here, let's try it here. Import GeoPandas. Maybe it died. No?
Yeah, no kernel.
Yeah. I want to make this point, so bear with me. Yeah, so module not found error. No module named GeoPandas. So in this binder computer, we haven't yet installed GeoPandas. And then of course there's not much you can do about it. We have to do the installations, but if you're working on your own computer, there's some hints on where to get started. So we recommend once you start working on your own computer, install Anaconda, and then there's this Conda package management system that you then use for installing. So often it's as simple as Conda install package name. It's kind of a command line thing to do. And then you will have installed the packages on your computer so that you can import the packages in your scripts. It's a bit same as referring to R. You first have to install the packages and then you load the packages. Yeah, and then another, yeah.
One small thing just about, with Conda, it's also possible to do things like this thing we have for using Git inside the Jupyter Lab system, the little extra tab there that you have available. That was installed using Conda. So you can also, like, it can install Python libraries, but it can also install other stuff related to the Python environment, like things related to Jupyter Lab. There are other extensions that we're not using here. And if you go browsing around looking for Jupyter Lab extensions, maybe there are some cool things you would like to try out using on your own computer, and you can also install those using Conda. And 90% of the time you can just like look for the name of the extension and you'll see like someone just says copy paste this like Conda install line.
Yeah.
And
Yeah, so there's excellent documentation on this. Just to repeat, this is completely extra. You don't need to start installing things, but I hope that you get excited about installing things, so then you can look for more information. Another thing or place to be aware of is the kind of Python package index. So if you would create an awesome package, you could kind of wrap it and put it to Python package index and make it available for anybody. Why not? And then there's this tool pip that is used to download Python packages from there. We would recommend you to use, if now starting from scratch, just use Anaconda, install things with Conda, but if you use some more kind of exploratory packages or more complicated things, you might not find them through Conda, so then you need to use pip. I don't know if you have other comments on pip.
Well, let's see if is that, okay, now it's alive. Yeah, it's also the case that there's a lot of older packages that are available only through pip.
Mm-hmm.
So if there's things that aren't being actively maintained but are still usable, sometimes you can't find them in Conda because the developer is no longer updating it, and so the package is available. Pip, I think, was it predates Conda.
Yeah.
And some things are available in both, but older stuff I often find only in pip.
Yeah. So indeed, for managing, installing, checking the list of modules, you don't need to do it, but if you want to use Conda, there is a way to check in Jupyter Lab, just like what all do I have GeoPandas installed in this environment. You can run help modules, but you'll get first some errors complaining about deprecated stuff, and then you'll get a list of modules. So I might not just run it here because just to keep it clean, but if you want, you can run this help modules, so you'll get a list of modules at the end. Cool. Any further questions? Yeah.
So I'm a little confused about how often you have to import the modules, like especially in terms of using the Jupyter notebooks. So
Yeah.
for example, last week we had problems like 1, 2, and 3, and
Mhm.
they're all in separate files.
Yeah.
So let's say for problem 1, I import math,
Mm-hmm.
and then I use it. For problem 2, would I also have to import math again?
Yes.
Use this function?
Yes. So always because as you have noticed, you have to have the things in memory for the next cell to work. So now that we have the kind of each problem is one entity, and you always start, be it a Python script, a module, or then your kind of one thing that you run. Eventually you would run all cells as an entity. So you always start by importing the modules you need in the consecutive code blocks or lines of code.
I think from the standpoint of how the Jupyter Lab and Jupyter Notebook system works, I think each file is sort of seen as a separate kernel, and anytime you're working with a different kernel, it's essentially like a little Python environment, and if you want to use something, you have to import in that file.
Yeah.
Yeah.
Yeah. And similarly, if you're using functions, you either have the function definitions at the top, like first you import things, then you define functions, and then you use the functions and imported modules. But then of course some of the functions you are using are kind of imported, so they are defined when you do the import. So you have to have the function definition in memory so that you can use your temperature converter function. So yeah, I don't know if that made it clear, but you always have to, when you have a new file, you always have to start by importing the required modules. Okay, that's that. One more point, kind of, I guess this is our good coding practices number 4, even if we don't have the title in here. Again, Dave covered most of it today and during week 2, I think, but just a bit of repetition. So writing script files, of course, you can now in the context of this lesson, we are just putting the function definitions in this py script file and then saving that as a module. But you could, of course, also just have these other types of Python statements in a script file. So the same rules apply. You use inline comments when required, and then in addition to inline comments, use kind of line breaks sparingly, but when needed. So just without reading, you can notice that, okay, there's a lot of information in there. but this code block in here is already a lot more easy to read. So if you go like whoa, when you see like super much text just crammed, so maybe you want to add some empty lines, that's repetition. Then the docstrings. So Dave discussed about adding docstrings inside the functions. So you first have the def function name, maybe parameters, colon. Then on the first indented line you have the triple double quotation marks. You can have a one-liner as you saw. Then in script files overall, so it's good practice to start the script file with a documentation string, so a doc string. Maybe I'll jump in here and see if we actually did that, because I don't remember. Yeah, so in this now temp converter, we only have doc string in this first function. You should of course add a doc string to the other functions, but in addition to those, always start if you have this kind of blank script file, so triple double quotation marks, Jupyter Lab will automatically kind of do the starting and ending. So if I now only pressed 3 times the quotation mark, now I have 6, and then maybe a few line breaks. Then in the kind of script file docstring, you should describe what does it do, maybe who authored it, how do you use it, and so on. So I don't know here, maybe I won't do this perfectly, but functions to convert temperatures. Yeah, and then we would have author is Dave. Am I following the? Yeah, maybe date. Yeah. So these sorts of things, there are different kind of, again, best practices on how to format the docstring. But then again, once I would save this file and then reload the function, so if I would call and import this module, if I would call help module name, I would get this piece printed on the screen. So it's again kind of facilitating the usability of the code, telling yourself what it does and telling others what the script does. There are some like tiny little formatting details, so the kind of ending quotation marks should be on a new line. So that's kind of a pep detail, but it's a good practice to do so. We haven't discussed how to run Python scripts using the Python interpreter, but that's related to that. And then in addition, you could, for example, add a license to your script. Maybe Dave wants to mention something about the license.
Yeah, I mean, I guess I can just say that it depends a little bit on the situation. Like, if you've created a repository on GitHub, there are options in there that you can directly choose a license. So depending on how you want to restrict usage of your code, it's a good idea to think, especially if it's on GitHub or other. There are, I don't know how many millions of users on GitHub, 50 million or something like that. It's a pretty big coding platform. If you put something up there and you don't want it used for some evil corporation to profit off your work, you can choose a software license that says it's not okay to use the code for commercial use. Someone can't profit off your code or whatever. This is an example of the MIT license that's here. MIT license basically just says you can use the code however you want, and I'm not liable for anything that goes wrong. So that's a useful thing too. I mean, if someone uses your code called investmoneywisely.py and it drains their bank account, if you have an MIT license on there, you can say, look, the code maybe misled you, but I'm not liable. You used my code, and you used it subject to the license as here. It's provided, as it says here, as is, no warranty, it's up to you. So the license can be really important because it basically ensures that if there's something where you wanna make sure you get credit for the use of the code, you can have a license that says that. If you want something that says someone shouldn't profit off this, if you wanna say that if you take the code and modify it, you have to use the same license in the future, there's also licenses that have those kind of restrictions built in. And Volko was opening this website, choosealicense.com. You know, maybe you don't see yourself at the moment needing to choose a software license, but this is a website where it allows you to kind of quickly read through what the sort of key things are for the piece of software you have. And if you want to, you know, keep it simple, they say use the MIT license. If you want to make sure that anyone who shares the code uses the same license you have, they recommend the GNU GPL version 3. But there's a whole bunch of these different software licenses out there, and you can read more about them on the webpage as well. GitHub is nice because when you create a new repository at GitHub, it has templates for a lot of the popular licenses that you can automatically add a license file to your repository. And again, that just makes sure, like, for all of our course materials, they are on GitHub, and we have license restrictions there just to make sure that we don't want someone to take our course stuff and then, like,
Sell it.
modify it and not allow other people to use it. We try to use a license that says if you're welcome to take our stuff and modify it, but you should make sure that it's still openly available to anyone who wants to use the course materials.
Yeah, great. But the most important things to know, like use a docstring at the start of the script file and inside your functions. Two things. And indeed you can have these multi-line docstrings or then single-line docstrings. And you can check for more documentation. There are nice ways to make multi-line docstrings for functions as well. And we can provide links to those on Slack. Why not?
Yeah, there's also certain formats. If you put your docstring into the right format, there are ways inside Jupyter to see a little bit nicer looking documentation where it like puts certain headings in bold and whatever. I can't remember what the deal is with that, but yeah, there are some standards there that make it easier to read and easier to use.
Yeah, but like minimum requirement, have a docstring and have a sentence in English telling what you're doing, so that's already awesome. Okay, I guess that's it. Do you have questions about docstrings, script files, modules? Yeah. Of course, then there is this week's exercise.
I think it's already open
That
there.
is, oh, you have it open.
Yeah, it's fourth for
that one.
Yeah. Should be.
Yep. We have 3 problems. Each one of them is a separate notebook. So if you import things, you need to import them in each 4, 3.
Problem 0.
Ah, yes, of course. Yeah, we have 3 coding problems and then problem 0. So we are now, well, more than halfway through the course, 3 weeks left. So we would like to ask for kind of structured feedback. So there's a little e-lomake form. Please fill that in before next week's lesson. We highly appreciate all the kind of continuous feedback, but also through this. So be honest in there. And then the 3 problems, in principle, you will be making functions in problems 1 and 2, and then you'll be applying them in problem 3. That's the overview. Let's hope this loads. So, reminder, give us the feedback. Then problem 1, you will do a function called far to Celsius. So it's kind of the same idea as Dave showed in today's lesson. You just now need to apply it kind of the other way around. So create a function, test that it works, and then again, now we have maybe a bit restructured the tests. So the idea is that you do your solution in here, use it a bit, demonstrate with some values, and then finally you can run these read-only code cells to see that your solution is somewhat correct. You shouldn't see any errors when running these code cells. If you do, there's probably something wrong in your function. But also, like if the tests all pass It's of course not a guarantee of 100% correct answer, but hopefully that's the case. And then we have some additional questions to you. And at this point of the course, we also start checking that you have actually commented your code, you use docstrings, you use the given variable names and so on. So kind of the readability of the code will also be worth of points. So make sure that your code not only works, but also is readable. Problem 2, there's the same kind of classification scheme as last week. So you can of course recycle some of your code, pay attention to the threshold values that you actually got them right. And then you create another function which classifies the temperatures. Again, your solution here, test it here, and then you can run these automated tests to check if things are going smoothly. So hopefully these tests help you to actually solve the problem. That's the point. And again, check that you have also formatted the answer nicely. And then in the final problem, you need to create a script file, as we learned today, and then basically copy-paste your nice functions from problem 1 and 2 to that script file, make a docstring, save it, and then using that script file and the functions in there, you should convert and reclassify a list of values that are in degrees Fahrenheit. So we have a bit more detailed instructions on how to do that. So here you'll need the functions, then you'll need a for loop, and then within the for loop, for each value, do the conversion, do the classification, and store everything in a list. So you'll end up with a list of Celsius you'll end up with a list of classifications in this case, and then finally you test your solution by checking how many values did you get in each class, and then a bunch of tests. So that's it, no optional exercises this week, but we can come up with some if you really want to do more than this. Yeah, any questions? No?
I have a question maybe for you folks. Do these tests make any sense? Like when you look at this stuff, you don't need to make any changes there, but do you understand the reason why they're there? Yeah, I mean, unfortunately there's no really easy and transparent way to like hide these tests in the Jupyter notebook, so that like you just have one cell you run and it automatically runs these things. We use an automated grading system with the tests, and in order for them to be visible to you, we basically have to make them, well, in order for you to be able to check your answers, we have to make the tests visible. So it's a little bit clunky, but for the most part, if you pass most of the tests, or well, if you pass all of the tests here, then there's a very good chance that you've done the problem correctly. So that's the nice thing, that you can check and know whether you're on the right track.
Yeah.
Especially when we get to exercises 5 and 6, where there's maybe a few kind of processing steps before you go and do something, or like exercise 7 where you process some data and then plot it. It's nice to know that like the earlier stages you produce the right output that you then later plot. So that's the kind of idea with the tests, is checking before you get to stage 5 that everything is okay in stages 1 through 4.
Okay, so yeah, there's the practical sessions Thursday, Friday. Remember the feedback, and yeah, see you latest next Wednesday.